Hi, everyone. In this video, we're going to be discussing Boyle's law, which compares pressure and volume of a gas. Now, when we're looking at pressure and volume, we are assuming that temperature and the moles of the gas are constant, so they're not changing. So we're only looking at pressure and volume. And the relationship is if you decrease pressure, you increase volume, or if you decrease volume, you increase the pressure. So using the combined gas equation, if temperature and moles of gas aren't changing, we can eliminate them. And so we simplify the expression to be pressure 1 times volume 1 equals pressure 2 times volume 2. And this is known as Boyle's law. This is the scientist who discovered this relationship. The reason we have a picture of lungs on the cover photo here is because Boyle's law explains how breathing works. So in your lungs, you have a muscle called your diaphragm, right? And when you breathe out, your diaphragm compresses and your rib cage contracts and it shrinks your lungs. And so because they're shrinking, the pressure in your lungs increases, which causes the air to be exhaled. And when you're inhaling, the diaphragm moves down, your lungs expand, and it creates a low pressure zone, so air enters your lungs. So let's do some practice problems with Boyle's law. So Freon CCl2F2 was used in refrigeration systems. What is the new volume of an 8-liter sample of Freon gas, initially at 550 millimeters of mercury, after its pressure is changed to 2200 millimeters of mercury at constant temperature and moles? So we're using Boyle's law, P1 V1 equals P2 V2. They give us an initial volume of 8 liters. They give us an initial pressure of 550 millimeters of mercury. And they give us a final pressure of 2200 millimeters of mercury. And they are asking us to find the final volume. So let's rearrange the equation to get final volume by itself. So we need to get P2 to the other side. So if I divide both sides by P2, that cancels. And so we have volume 2 all by itself is equal to P1 V1 over P2. Now all we have to do is plug in our numbers and punch it into the calculator. So initial pressure was 550 millimeters of mercury. The initial volume was 8 liters. And the second pressure was 2,200 millimeters of mercury. Millimeters of mercury cancels. We're left with liters, which makes sense because we're solving for volume. So if we punch that into a calculator, 550 times 8 divided by 2200, I get 2 liters. And it looks like we did it right. Let's do another one. A sample of oxygen gas has a volume of 12 liters at 600 millimeters of mercury. What is the new pressure when the volume changes to 36 liters at constant temperature and moles? So once again, we're going to be using P1 V1 equals P2 V2. They give us an initial volume of 12 liters. They give us an initial pressure of 600 millimeters of mercury. And they give us a new volume of 36 liters. And the new pressure is what we are looking for. So let's get pressure by itself here. So if I divide both sides of the equation by V2, V2 cancels. Now we have P2 all by itself equal to P1 V1 over V2. Let's plug in our numbers. Pressure 1, 600 millimeters of mercury. Initial volume was 12 liters. Final volume was 36 liters. Liters cancels. We're left with millimeters of mercury, which makes sense because we're solving for pressure. So P2 is equal to 600 times 12 divided by 36. And that will be 200 millimeters of mercury. And it looks like we did it right. So once again, to recap, Boyle's law compares pressure and volume. You can derive it from the combined gas law. If moles and temperature don't change, the expression simplifies to P1 V1 equals P2 V2. Thanks for watching, and I'll see you in the next video.